If you're a software engineer who uses AI, or you're a machine learning engineer, knowing about vector databases and embedding is a must for you. In this video, we're going to talk about what are vector databases and embedding, why do we use them, what are the best options, and all we need to know about them to get started. Let's start with a question. Imagine we have two different texts or documents that we want to compare with each other and see how much are they similar with each other. 80%, 90%, 0%. What are our options? Well, we can manually check them, but we want to use automatically, absolutely. So we need to use AI. Imagine we're sending both of them to ChatGPT and we're asking it to tell us the similarity between them. Does it work? Yes, it does. Is it professional? No, it's not. Why? Because it's going to cost a lot and it's going to take a lot of time. Imagine we're doing it at runtime. When a user is sending a request, so it's not possible to do it with OpenAI, ChatGPT, or any other AI model. What should we do? Here, we talk about embeddings and vector databases. Let's show you a picture. Look at this picture. We have a text, a striped blue shirt made from cotton. What if we could convert the text into numbers, an array of numbers? So if we could compare any text to numbers, we could easily compare them. Is it possible? Yes, it is. How? With embedding. Embedding is a way that is a method that converts text into array of numbers, so computer can understand them. Well, look at these numbers. Humans cannot understand it, but look at them like lat and long when working with maps, when working with GPS. We can easily understand the position with lat and long. And using these numbers, computer can understand the position of the text, can understand the meaning. For example, cat and dog are similar to each other with these numbers because their meaning is similar. It's very exciting. It's very exciting. Look at this image. I have two different texts. A striped blue shirt made from cotton, which when I embed it, we have these numbers, and cotton-made maritime shirts, which after embedding, we have these numbers. Look at the numbers. They're really close to each other because the meanings of these two sentences are close to each other. You see, we can easily compare them now. We can say how much they're similar to each other. So the process of turning and converting this text to these numbers is called embedding, okay? And the question is, we have this, but where should we save it? Should we save it in SQL Server? Should we save it in MongoDB? What is the best approach for that? Let's talk about databases. Well, we can put databases into three categories. I'm not going to talk about relational and non-relational databases, not that kind of categorizing. We have OLTP database. OLTP stands for Online Transaction Process. It's a process of transactions. For example, PostgreSQL is an OLTP database. SQL Server, MongoDB, Oracle, they're all OLTP databases. They're good for transactions, for adding data and updating it, even deleting it. They're great for it, okay? And as you can see, we have rows and columns and we store them in this way. The other database type is OLAP, Online Analyze Process. They're not good for transactions. They're not good for updating data. They're very good for analyzing the data. They have fast performance in analyzing. What are the examples? Well, Amazon Redshift, Google BigQuery are two popular options when talking about OLAP databases. But what about vectors? What about these numbers? Where should we save it? Which database is best for them? Well, vector databases are a different category, and they are optimized for vectors. That's all. That's the only data we save into them. We're going to talk about them more in just a minute. We have different vector databases like Vespa, Qdrant, Pinecone. In this video, we're going to talk about Qdrant. It's one of my favorites, and I use it in .NET. It's very developer friendly. Well, in this picture, we have some useful information provided by Qdrant, and thanks to their team. First of all, in other databases, we have tables. Here we do not have tables. We have something called collections. It's really similar to tables, just the name is different, let's say. But collections contains the data, contain a size, the size of the collections, and they need an algorithm for finding the data. The algorithm is different. In Qdrant, we have three different algorithms. The first one is cosine similarity, dot product, Euclidean distance, and that's all. Well, in this video, we're not going to get very deep in mathematical courses and talk about each algorithm. But if you want to compare text and documents, the best option for you is cosine similarity. In cosine similarity, the response would be between -1 and +1. -1 means these two texts are not similar at all, and +1 means they have the most similarity together. In other databases, we have rows and columns, but in these kinds of storage and databases, we have something called points. What is a point? A point has three different parts. The first one is ID. ID is a unique identifier, and it must be unique. We save it here. That's okay. The second one is vector. Vector is our array of numbers, which we save it here. And the third one is payload. What is a payload? In payloads, we can save a JSON that contains our additional information. Let's give you an example. Imagine you're a software engineer at Spotify or Apple Music. You want to save musics as vectors in Qdrant. What should we do? Well, of course, we can easily give a unique ID to that and save the vectors. But when we are loading the data, we want to understand which music is it? Who is the artist? Okay, how can we understand it? We have only vectors and an ID. In the payload, we can save the music ID, we can save the artist name, or whatever you need when fetching the data. It gets a JSON object in this field. When storing data in Qdrant, we have two options for our storage. The first one is in-memory method, which saves the data in our RAM and has the highest performance. And the second option is memap. The memap is a way that it's a method that creates a physical address in a computer and saves the data in there. Don't forget that we can use embedding and vector databases for images, videos, audios, and even text. So it can help us a lot. Recommendation systems are using vector databases and embeddings. If you want to embed, the easiest way, in my opinion, is to use OpenAI API. Of course, it's going to cost for us, but it's very cheap. It's very cheap. You can easily use that and turn text to embeds to an array of number. And if you want to start with Qdrant or any other vector database, you can install it on Docker and run it locally. As I know, Qdrant supports the cloud platform, which is not free actually. It has a free period, but it's not free. And if you want to use it locally, you have three options to use it and integrate with it. The first one is the GUI. It's usually on your 6333 port in your local host. The second option is using API clients and using API. And the third option is to use gRPC. Well, it supports gRPC. It's usually on port 6334. Personally, I use gRPC and I prefer it. And it's really developer friendly. The documentations are clear. Maybe record a video about Qdrant and how to use it. But you can use whatever vector database that you want. Thanks for watching this video. I hope you enjoy it. Please like and subscribe if you like, and tell us your opinion in the comments below.